Hello and welcome back to PA Academy. So this is a continuation on the lecture series on signal and system. And in this particular video, we are going to be looking at even and odd signal. So before we get into this video, if you are new to this channel, kindly take our time to click on the subscribe button. And if you missed the previous part of this lecture series, kindly check the playlist on signal and system. You'll find the links to all of the videos under this lecture. Alright, so to start with, let's look at the definition of even and odd signal. Alright, so you might need to take this down. So when we talk about even signal, alright, so even signals, these are signals which remain identical after undergoing folding operation. That means time reversal. So what that is saying is that if you have a signal x of t, so if f of x of t is equals to x of minus t, so such a signal is said to be a even signal. So again, like definition I gave earlier, I said for even signal, a signal is said to be even when it remains identical or the same after undergoing folding operation. Now, folding operation is the same thing as saying when you mirror the signal. It's also the same thing as saying when it undergoes time reversal. So now let me give you an example of what we are saying. Now, if you have a signal like this, so okay, let me make it better. All right, so if you have a signal like this, and then now what you discover is that if this is our x of t, so if this part is our x of t, now you see that if I should mirror this signal, that means if I have it like this, okay, now if I should flip this signal along the y-axis, if I should fold it, I'm still going to have the same signal. It's still going to look like this. Exactly. So this will now be my x, okay, this will now be my x of minus t. Exactly. So you can see that what we are having here, they are both the same thing. So once you have a situation like this, you can say it is an even signal. So again, like the definition says, even signals are signal which remains identical after undergoing time reversal. Exactly. So that's for even signal. But once you are having a signal like this, so for odd signal is just the opposite. So odd signal is just the opposite of even signal, such that if you have x of t, when your x of t, okay, when your x of t is not equals to x of minus t, exactly. So at that point, you can say it is an odd signal. All right, odd signal. Odd signal. So let me just give you an example. For example, if you have a signal like this, now this signal is for example, if I should flip the signal, or if I should mirror the signal, then it's going to look something like this. So if I should flip it along the y-axis, it's going to look like this. So you can see that they are not similar. They are not looking the same thing. So we can conclude that if this is our x of t, and this is our x of minus t, so that simply means that our x of t is not equals to our x of minus t, and this is an odd signal. So that is how we can differentiate between even and odd signal. Now let's take it a step further. There are some things you also need to note when dealing with even and odd signal. Now for your okay, for the even and odd parts of a signal, so you might need to also note this. So the even part of the signal x of t is given as x of t plus x of minus t over 2, and then the odd part of a signal is given as x, that's the odd, is going to be o, is x of t minus x of minus t over 2. So just take note of the difference. For the even part, there is a plus here, and then for the odd part, there is a negative here. So That's the basic difference. All right, so let's continue. Still under even and odd signal. So now let's quickly solve this question under even and odd signal. So now with this signal that you are seeing on the screen now, and we are asked to sketch the even and the odd parts of the signal. So the first thing we are going to do, let's first of all establish the x of minus t. All right. So for this now, if you have to sketch the x of minus t, we are going to be having something like this. That means you're going to be flipping the signal along the y-axis. So it's going to look like this. Okay. So this is going to be 1 and this will be 2. So here we are going to be having it as x of minus t. Exactly. So at the same time, we are going to be to sketch for the minus x of minus t, and that will look like this. So what that means is we are going to be flipping the x of minus t along the x-axis. So we are going to be having something like this. So here is going to be minus 2, and this is going to be 1. And here we are going to be having, okay, let's write it here. It's going to be minus x of minus t. So with this now, if we are now asked to sketch for the even and odd parts, so what we are going to do, let's start with the even parts. So let me write here that for the even parts, remember that I gave the formula earlier for the even part of, okay, for the even part, which is this, so which is this formula here. So let me come back and repeat it here. So which is, so for the even part, x of e of t is equals to x of t plus x of minus t over 2. So you can also rewrite this as 1 over 2 into bracket x of t plus x of minus t. Alright, so for us to draw what the signal will look like, what we are going to do is the x of t itself, which is this signal itself, exactly, and this x of minus t, which is this signal, we are going to bring them together. So in doing that, so we are going to be having a signal that looks like this. So this, so this is x of t, this part here, we've done it here. The next is we are going to add it to x of minus t. This should be the brackets here. Let me correct that. So this should be, okay, let me just erase everything there. So plus x of minus t. All right, so now we've already done for x of t. So now let's bring in x of minus t, and this is for x of minus t. So we are going to bring them together, and x of minus t is having a signal in this form, so it's coming like this. So it's going to be like this. And don't forget over 2. This over 2 is going to affect the amplitude. That means you're going to be dividing the amplitude by half. So don't forget the amplitude of the signal itself is 2. So now we are going to be having this place to be 1. And then here is still going to remain as 1, and this is going to remain as minus 1. Now what we are having here is the even part of the signal. That means we've just answered one part of the question. Remember they said sketch the even and odd part of the signal. So here we've been able to sketch the even part of the signal, applying this where we get x of t plus x of minus t. Now let's sketch the odd part. Now for the odd part, So the formula is also given as x of t minus x of minus t over 2. So you can also write it as 1 over 2 all into bracket x of t minus x of minus t. So what this means is we are bringing in x of t together with minus x of minus t. So just like what we did earlier, let's first of all draw that of x of t. So x of t, let me show you again. So this is s of t. So it's looking like this. So this is for x of t. Now let's bring in minus x of minus t. So minus x of minus t, this is it here. So let's bring it together. So let me extend this. Okay, so let's just confirm. So you can see it's just here like this and the dashes along this part. All right, so I will bring it together. So let me just indicate that this is for minus x of minus t, while this is for x of t. And then here is 1. We have it to be 1. If you check it, if you check here, this is 1. And then so here we have it to be minus 1. Now something will also happen to the amplitude. Only the amplitude that will be affected by because of this half here. So the initial amplitude of the signal is 2. So but now that we are going to be having it divided by 2. So this is going to be 1 and this is going to be minus 1. So with that, now we've been able to sketch the even and odd. So what we are having here is for the odd parts. And then while what we have here is for the even part of this particular signal. This is the initial signal that we are giving. Exactly. So that is it on how to sketch the odd and even part of a signal. Exactly. So the first thing, if you are given the signal, you go ahead and draw and sketch the even parts, something like this, like the time reversal of this. Now once you get this, you are going to use this to get your minus x of minus t. Now the next thing you're going to do is for you to now sketch the main even part is to remember this formula. You bring in the x of t and then the x of minus t, you bring them together under one sketch. Exactly. And then the only thing that would have to change here is the amplitude. Exactly, because we are dividing it by half. And with that, you'll be able to get your even part. Then to get the odd part, you bring in your x of t and your minus x of minus t. You bring them together, and don't forget the amplitude will reduce by half. But this part will remain the same. Exactly. All right. So I hope you find value in this. That is all I want to cover under even and odd signal. All right. So in the next part of this, we are going to be looking at the next one. Let's see. So we've looked at okay. So we've looked at periodic and aperiodic. We've looked at even and odd. So the next one we're going to be looking at power and energy signal. So I hope you find value in this video. If you do, please give the video a thumbs up. And if you have any question or doubts, do make sure you leave them in the comment section below. So with that, I'll see you all in the next lecture series.